have written that we should immediately look up the concept of atomic and molecular activity. Now, these term I have highlighted because we are talking about in the molecular level. Then what is happening in the molecule when you will transfer the heat? What is happening in the molecules? Because the process at these levels sustain this mode of heat transfer. Conduction may be viewed as the energy of as the transfer of the energy from more energetic to the less energetic particle of a substance due to interaction between the particle. Means one temperature should be higher, another will be lower, then only heat transfer will take place due to conduction. Consider a gas. Here is the one example. Consider a gas in which the temperature gradient exists and assume that there is the no bulk or the macroscopic motion. Means he has clearly mentioned that there is no bulk and no macroscopic. Means you have any kind of compact gases, you cannot find any kind of motion, then how you will justify that where will be the heat transfer? But he has given it have the temperature gradient. Okay, one sided have the higher temperature, another one side have the lower temperature. The gas may occupy the space between the two surfaces that are maintained at different temperature. Okay, as shown in the figure 2. Let's go for figure 2. Now have a look. We are talking about conduction. This is the elevated temperature. T1 is higher than T2. Here is the T2, here is the T1. You can say here is the two plate, one plate, another plate. This plate temperature is higher, another one is lower. Now next what I have written, this energy is related to a random translation motion as well as to the internal rotational and vibrational motion of the molecule. Now these things you have to keep this in mind, what I am saying, because we are talking about in already molecular level. Then you have to check which mode, which kind the heat is transferring from one position to the another position. Then we have to look that we have mentioned that this energy is related to random translation motion as well as to the internal rotation and vibration motion of the molecule. What does that mean? If you have gaseous molecule here, then it have the two type of the motion. One will be the random motion. Of course, it will strike here, it will strike here, it will strike here, it will strike here, and at the higher temperature of the molecule, it will cross slowly, and it will enhance the temperature at this particular next plate in the T2 plate. Okay. And another one, what random motion it is over, and another one we are talking about the vibration and the internal rotation. Means of course that molecule, that the gaseous molecule which will be in a spherical shape, then it can automatically rotate means like this, it can rotate like this, can rotate like this, internal rotation. And what is the second term? That the vibration. Of course there will be the vibration. The higher temperature are associated with higher molecular energies. When the neighboring molecule collide, as they are constantly doing, the transfer of the heat from the more energetic to the less energetic molecule must occur. We may speak to the net transfer of energy by the random molecular motion. Okay, as here what we are looking for at the molecular level, so definitely we have to look which kind of molecule they are, and which kind of that molecule, which kind of transferring heat from higher temperature to the lower temperature. Now we have got the three terms: random molecular motion. In the random molecular motion, as well as what we are talking about, rotational and vibrational, three terms we have got. Now have a look for that profile as well. In the profile, the temperature is very high at this point, and here temperature is very low, T2. Why I am every time looking for profile? Because profile justifies your flow behavior, how the fluid or any kind of, this is your pipe, this is your pipe. If fluid will flow at this direction, if you will check the velocity with no slip condition, how how it will look like. It will be look like this. Means you will claim at this particular position at the middle of the pipe, velocity will be very high. It will be equal to u max. Okay, here at the middle of the pipe. Now have a look for the heat transfer. Heat transfer, you are claiming that T1 is the higher temperature, then definitely at this temperature, at this point will be very higher, and it will be lower. It will be in curve form, and it will be at the lower position. Means heat transfer will takes place from higher to lower. But this is the flux. Okay, this is the flux. Means how much is heat is transferring from T1 temperature to T2 temperature at x distance. Means this is your distance which is flowing. That's why we have written qx. It is showing your direction, at which direction it is flowing. Now it is flowing from here to here, then here it is your x, then fluid is flowing from T1 to T2. Okay, I think you have got little bit idea about how the conduction is takes place now. But you have read in your literature, you have read in your in 12th class that conduction takes place only when you are talking about the solid particle, not in gaseous form, not any kind of in any kind of liquid. But it is not the correct thing. Why correct? It is not a correct thing, because in earlier that is the correct, that when the fluid it will be stagnant, then only it will say there was one star mark. Because at the initial, of course, conduction will take place in the solid only, but there is the one condition you have to read, that when the fluid or when the gas will be at the stationary or the stagnant position, then only conduction will take place. Don't forget this line. Fluid or any kind of gas, any kind of solid should be in a stagnant position, stationary position. Now for I have now we have read that there is the some kind of random molecular motion. Due to that reason, there is the transfer of heat. Okay, now the situation in which the same in the liquid, now clearly written, same thing will happen when you will talk about the liquid. Although the molecule are more closely spaced and molecule interaction are stronger and more frequent. Means if you will talk about the liquid, the heat transfer will be very high, because here the molecule will be very compact. In the solid, what is happening in the solid? Now the conduction may be attributed to atomic activity in the form of lattice vibration. As I already told, there is the two type of vibration. One is will be that the vibration and the rotation. Then here lattice vibration. Lattice means generally if you have any kind of material, like this is your sheet, iron sheet, iron sheet. Then what does that mean? Here the molecule, all the atoms will be in arranged manner, manner, like this. All position will be round down. Like what is the structure? If it is round shape, it will be like this. Means it will be in arranged manner. This is called as the lattice. And lattice means if you will increase the temperature at this particular point, that it is the T1 temperature and this is the T2, and T1 is higher than T2. Sorry, it is very tough to write using mouse. Okay, sorry for this. And how the heat transfer will take place? Here will be the higher, here will be the lower. The profile will be like this only. And the heat transfer will take place due to the lattice vibration. Means this atom will strike to nearby this atom. After that, this atom it will strike to this atom. Due to that striking, the heat transfer will take place. Now we will look more into that conduction. The conduction is the transfer of heat from one part of substance to the another part of same substance. Now same substance, or from one substance to the another in physical contact with it, without appreciable displacement of the molecule from the substance. Now how heat transfer will take place by two mechanisms. One will be your lattice vibration, we have already discussed, and the transport of the free electron. Free electron, okay, let me show one video for you. Now, have a look how the conduction will happen in the solid. This is your any kind of lighter. This is your solid particle. Means you have any kind of plate or any kind of iron, iron sheet. Then how the heat transfer will take place? Now have a look. What we are talking here. It will increase the vibration. Now it is vibrating and heat start flowing from this position to this position. Now it is vibrating and it is rotating as well, and due to the random collision to each other, the heat will transfer from this position to this position. Now it is the red position which is increasing in this direction. I think you have got my point, how the conduction takes place in a solid surface by the two. One is the lattice vibration, another one is transport of free electron. Now, if you're talking about the gases, as I already told, the mechanism of heat transfer is simple. The kinetic energy of the molecule is the function of temperature. Means more collision will enhance the temperature from higher to lower. These molecules are in continuous random motion, exchanging energy and momentum. When a molecule from the higher temperature region collide with a molecule from lower temperature, it loses energy by collision. Now I have already shown in video. Now in the liquid, the mechanism of the heat transfer is near to that of gases, but here all the molecule will be closely compact manner. So heat transfer will be in liquid, definitely will be higher. Now we have got little bit idea about the heat transfer. Then how you will define that heat transfer? Very famous equation, that Fourier's law of heat conduction. It is the full name, means Fourier's law. Okay, but what it signifies of the heat conduction? Fourier's law of heat conduction. The heat transfer process can be quantified in term of appropriate rate equation. The rate equation may be used to compute the amount of energy being transferred per unit time, because we are looking for how much of the transfer will take place from one position to the another position with how per unit time, which is defined by the Fourier's law. Now, what is the expression for the Fourier's law? This is the expression: Q is proportional to area. How much is the area where the heat transfer will take place, multiplied by del C by del T. It is the temperature. T is the temperature. Delta T by delta X. If you have this any kind of cube, now if you are looking for heat transfer from this position to this position, or you have any kind of wall, solid wall, any kind of wall, then you have to look how the heat transfer will take place. This is the completely filled, I mean this is the solid surface. Then you have to determine how much is the area. What will be the area? Length. How, this is your L, if you will say this is your L, and this you can say your width. The L multiplied by V tell you the area, how much is the area. And how you will define the del T by del X? Del X, if you will cut a small segment like this, if you have cut a small segment here, that will be del X, and how the heat transfer will take place at this particular position, means how the temperature will change at this small segment, at the delta X segment, which is called as delta X, del T by del X. Now, to equate this whole equation, you have to multiply it by one term called as the K, which is called as the thermal conductivity. Now here I have written everything. Q is the heat flow through a body per unit time, which is also denoted as watt. Area, surface area of heat flow, as I already told, means how the heat transfer will take place. Okay. and unit is meter square. The T is the delta T is temperature difference from one phase to the another phase. Delta X is the thickness. How much should be the thickness? How much would be how much will be the thickness of the sheet? And this is your complete formula. K is the thermal conductivity. And why negative sign? Negative sign means you are defining your temperature increasing direction of the heat transfer. Okay, means if the heat transfer will happen, this is your surface from this direction to this direction, then your profile will be like this only, temperature profile. Then here you see, here temperature is very high at this surface and here temperature is very low, means you are moving from higher to lower. So that's why this negative sign define this term. Okay. Now this is all. I have given one picture also. Now you can see when the heat transfer takes place from this position to this position. Okay. Then this is your profile. This is your profile, how the heat transfer will take place. This is the T1 and this is the T2. And this is the how based on the distance, it is based on the distance we have denoted as the Tx. Okay. Now, what are the assumptions that we have made to define the conduction term? Conduction takes place under a steady state condition. First, steady state condition. Heat flow is unidirectional. Second is the unidirectional. Temperature gradient is constant and temperature profile is linear. Means there is not any kind of deviation. Temperature profile means like this only. If there is any variation, if the like this, then it is not applicable. Then you have to define your first of all area. You have to cut it down in different segments. Then only you can use this Fourier's law of heat conduction. Now there is no internal heat generation. If you have any kind of if you are using any kind of material which can generate heat, then this is not applicable. So there is no internal heat generation. Bounding surface are isothermal in character. Okay, the material is homogeneous and isotropic, means the thermal conductivity, the value of the thermal conductivity is constant in all direction. Okay, some essential features of Fourier's law, that it is applicable to all matter, maybe solid, liquid, gas. It is based on experimental evidence and cannot be derived from first principle, because itself it is a first principle, and we are, by using the fundamental law, we are quantifying, we are determining our heat transfer, how much will be the heat transfer. Okay. And the fourth one, it helps to define the thermal conductivity, because here in this equation, this term, it is, you have to see what is that mean, what is the physical significance of the conductivity, because this is the proportionality constant. Now here I have mentioned also the constant of proportionality, means you have equated based on this k. Then how, what is it is signifies and what is the significance in your system? It is defined the thermal conductivity. What is that mean, thermal conductivity? First of all, this is the unit. We will check the unit. Its unit will be watt per meter Kelvin or watt per meter degree centigrade. Now the thermal conductivity definition, the amount of energy conducted through a body, amount of energy conducted through a body on a unit area and unit thickness, that the unit area and unit thickness in unit time, when the difference in the temperature between the phases causing heat flow in is unit temperature difference. Okay, have you got? Means we are saying that if you have heat transfer which is per unit area, this is your per unit area. Per unit thickness, we are looking for how small thickness will takes place. Unit thickness in unit time, unit thickness in unit time, when the temperature, when the difference in the temperature between the phases causing heat flow in unit temperature difference. Okay, this is the definition of the thermal conductivity, but how you will define and how you will signify from that equation, because this is the only expression how you will define into your material. Now we will first of all look that what does that mean. It follows from the equation that the material with high thermal conductivities are good conductors of heat, whereas the material with low thermal conductivity are good thermal insulators. Means thermal conductivity, if the material which is highly conducting, if you are saying which is highly conducting, then it definitely will it will have good conducting property. The material with the lower thermal conductivity, which is having lower thermal conducting activity, or you can say it is the good thermal insulator, means it will resist to flow heat transfer from higher temperature to the lower temperature. Now we will look into some examples like you have silver material. Now you can see this is the silver. The thermal conductivity 410 watt per meter Kelvin. Now this value is very high, but if you will talk about the glass or concrete, that heat transfer is very low. Okay. If any material which is having higher thermal conductivity, it will lose heat and gain very fast as compared to that the lower thermal conductivity. As if you are talking about the wood, I think here it don't have wood. If you talk about wood, it is very it have very less thermal conductivity. But any kind of metal like silver, copper, aluminum and iron, they are having the higher conductivity. Means they can propagate energy at very higher rate as compared to non-conducting material. Now these are the examples, and we will first of all see one uh, that example, that what we are saying and what we are talking about. Now there is one question: if you are in that if weather is very cold and you have two type of chairs, one is iron chair, another one is wooden chair, what would you prefer to sit? Means which will transfer more heat from your body to the chair? Just give me first of all what is the what would be the what would be the reason for that. Means what I am saying, if you have two chairs, one chair is wooden chair, another one is iron chair. If you want to sit, then which chair will transfer more heat from your body to the chair, and which will transfer lower heat from body to chair? Okay, tell me. Okay, let me tell. If you have one chair, if you have one chair like uh, what how you feel that body is cold or hot. Generally we touch the body and feel, this body is hot. If you are losing heat, then you will say that this is the cold. If you are gaining heat, then you will say, this is the hot body. Generally we do this kind of thing. Means if you have any kind of plate which have the high temperature, then you will touch, you feel, there is the some heat. Means that heat is giving you heat. When any kind of ice cream or any kind of thing which is colder than your body, when you will touch that surface, then you will feel that it is a colder body. Okay, because you are losing your heat from your body to that surface. Now if you are talking about that two chairs, okay, if you will choose one wooden chair, then what you will suggest, if you will sit here the heat transfer from your body to the chair will be very lower. Okay, because it has the very low thermal conductivity. So heat transfer, heat propagation from your body to the chair will be very lower. It will take so much time. But if you will talk about the iron chair, what will happen when you will sit into this kind of chair? The heat propagation from your body to the steel chair will be very high. Means heat propagation in this solid surface will be very high, not in solid surface, this kind of metallic surface. Okay. Now the same example, if you will talk about uh, if you have some kind of ice cream, if what would you prefer? Generally you get your ice cream in paper plate or any kind of that wooden plate, not in iron plate. Why? What is the reason behind? If it is, this is the metal plate, have a look. If it is, this is the metal plate and this is your wooden plate. Okay. When you will touch this plate, this is the very colder plate, very cold. But when you will touch, what you feel, this is the colder, because you are giving heat to that plate, means you are feeling it is very cold. Okay. If you will put the ice cream here, what will happen? Due to the heat transfer, due to the heat transfer in this plate, chocolate or any kind of ice cream will melt faster as compared to that wooden plate. What does that mean? It definitely it have such it shows the colder properties, but the heat transfer from the outer surface to that the inner material will be very high in the case of solid, in the case of iron or the any kind of metallic compound, as compared to this paper plate. Okay. So generally what people do, generally we get ice cream or any kind of colder thing in the paper plate or wooden plate or any kind of plastic plates, not in iron plate. That is the reason metallic, no one provide, no one give you ice cream in the metal ball or any kind of metallic sheet. That is the reason. Okay, now we have got little bit idea about the thermal conductivity, that if any metal or any kind of metallic part, generally it have the thermal higher thermal conductivity as compared to any kind of wooden or any kind of like glass surface concrete, it have the lower thermal conductivity. Okay. Then convection. Okay, I so up to here we will stop, because I think we should go very slowly, not very fast. And here we have talked about the conduction up to here, and we have talked about the fundamental law, Fourier's law of heat conduction. And here we also discuss about the thermal conductivity. Thermal conductivity means if any kind of material which is having, which is having the higher conduction property, so it will propagate more energy to transfer heat as compared to the wooden particle or any kind of concrete or any kind of cement kind of structure. And generally our home which is made up of concrete, because it has the lower thermal conductivity, not made up of any kind of our home generally made up of that concrete, because we don't want to lose our heat. Otherwise in in the colder place, or in the cold season, the room will be very cold, and at the hot season the room will be very hot as compared to normal condition. Okay. Okay, so tell me if you have any query. And first of all, we will finish this part, conduction convection, because in your curriculum it is written here the principle of conduction, convection, and what should be the critical insulation thickness. We will also discuss about this. Will be the very interesting, and all the basic fundamental laws of radiation, heat, that conduction and convection. Okay. Then we have discussed about only one fundamental, that law, Fourier's law of heat conduction. Okay, what is the formula? Q equal to minus Ka del T by del X. This formula. Just keep this in your mind. Okay. Now we will discuss in next class convection and radiation.